Welcome back to the Advanced Arduino Basic project, and today we will learning about traffic density control system. And here is the agenda: overview, components, principle, schematic, procedure of traffic density control system. In this lesson, we will program the Arduino to achieve the automation of an adaptive traffic management system. The system will automatically prioritize green lights for the road with the highest vehicle volume by using ultrasonic sensors to measure queue length. The required components are Arduino Uno, ultrasonic distance sensor, resistor and LEDs. So here we are using 3 LED, yellow, red and green. Next is the principle. The system operates on the principle of inverse proportionality between distance and vehicle density. So what this project will do? One is queue detection, comparative logic and state transition. The Arduino calculates distance using ultrasonic waves. A decrease in distance indicates an increase in the number of cars, that is higher density. The code uses a comparison algorithm. It subtracts the distance of lane B from lane A. If lane A has significantly lower value, it is prioritized for the green signal. When a lane is cleared, the distance to the sensor increases. The Arduino detects this change, initiates a yellow caution phase and then shifts priority to the next densest lane. And here you can see the schematic diagram. You get this diagram using Tinkercad. And next is the procedure. So here we are using 2 ultrasonic sensor and LEDs, resistor and microcontroller. And next is the procedure. First is the pin declaration of LED. Next, ultrasonic sensor declaration, sensor pin declaration. So here pin, echo pin and pin and echo pin. So this is nothing but trigger pin of the ultrasonic sensor. So the system is built on simple but effective rule. The shorter the distance measured by the sensor, the longer the line of the cars. If a sensor is 30 meters back and reads 5 meters, there is a long line of cars reaching almost to the sensor, that is high density. If it reads 30 meters, the road is empty, means low density. So here is the setup function. It tells the Arduino whether it is input or output. Here you can see all the LEDs are considered as output. And next is the loop function. So the code constantly compares distance 1 means road 1 and distance 2, that is road 2, to decide which light should be green. So here distance 1 is greater than or equals to distance 2. If road 2 is more crowded, means smaller distance, the code enters a while loop. It sets road 2 to green and road 1 to red. So here you can see it stays in this loop until the cars in road 2 move away and the distance increases. And second condition, distance 1 is less than distance 2. Distance 1 is greater than distance 2. This condition is distance 1 greater than or equals to distance 2. So here distance 1 is greater, right? So here distance 2 is greater than distance 1. So if road 1 is more crowded, it switches. It sets road 1 to green, then road 2 to red. That is the logic here. So before switching from one row to another, the code sets the yellow LEDs to high and adds a delay 200. Here you can see, yellow is high. So this mimics a real traffic light, giving drivers a warning before the signal changes to prevent accidents. So here we having the function calculate distance. So int calculate distance of int ping pin, int echo pin. So this is a custom function that handles the map for the ultrasonic sensor. It sends 10 microsecond pulse to the sensor. And here we using duration equals to pulse in of echo pin, high. So it uses pulse in function to wait for the sound to bounce back. So it converts that time into centimeters. Here you can see it converts time into centimeters, then divides by 100 to get meter value. So using meters instead of centimeters makes the number smaller and easier for the Arduino to compare quickly. The most important part of the code is the while loop. Here you can see. This ensures that the green light stays green as long as that road is the busiest. It doesn't just switch back and forth on a timer. It waits until the density problem is actually solved before the changing lights. And here you need to consider red 2 is high and green one is high, and rest all is considered as low. All you done, right? That's all about the program. Now we need to do the circuit part. So for this project we need 2 ultrasonic sensor, that also 4 pin. Then Arduino, just a moment, you will get it here. Arduino. Then we need breadboard to place the LEDs. Here I am taking 2 breadboard, and we need LEDs. Copy it and paste. So we need green, then yellow, and we also need 0.33 kilo ohm resistor. So we need 6. 3, 4, 5, 6, yeah. Now, so press shift, then like this. Shift, it won't work. So yeah, so here I am placing this LED, red, next yellow, next green, and here I am taking green first, then yellow, then red, Then so here this is cathode terminal, right? So I am connecting this cathode to this cathode. This is cathode terminal, right? So this one I am connecting it here. Then this terminal to here. Now all cathode terminals are shorted. Now we need to connect this to negative rail, and this is ground. I am connecting this to negative rail. Yeah, now one part is done. Now we need to take this resistor and connect this to here, anode terminal. So this is anode terminal, right? Yeah. And place this here, anode terminal, and even this is anode terminal, right? And this one. Yeah. Now we need to connect these two pin numbers. So here I am connecting this to pin number 8. So this is pin number 8. I'm changing it to different color. Before that, I need to connect this starting node. Yeah. Similarly, we need to connect all the resistor ends. This one I need to connect to pin number 7, and this one pin number 6. Similarly, we need to connect this also. So pin number 5, and this to pin number 4. And this one is pin number 3. Yeah, now connection part, this part is done. Now we need to connect this part. So here, zoom it, ground, and connecting ground to ground. So here we need to take 4-pin ultrasonic sensor, not 3-pin. Search it here, ultrasonic. So this one. Yeah. Now we need to short this both ground and ground. Then we need to connect this to here. Yeah. Next, VCC, power pin. Now we need to connect this 5 volt. Make it straight. Yeah, this is done. Now we need to connect a trig pin and echo pin. So here I am connecting this trig pin to pin number 12. And I am changing the color to brown. And this echo pin to pin number 11. Similarly, we need to connect this also. So here I am connecting this trig pin to pin number 10. So this is pin number 10. And this trigger pin to pin number 9. So here is the pin number 9. Now this part is done. Next, paste. Is the code. Start simulation. Now here yellow LED is glowing. Now just change the distance. See, red and green is glowing. Here also change it. Again yellow, green, red. So the output of this system is dynamic signal switching based on the real-time comparative data. So instead of a fixed timer, the traffic lights respond physically to the length of the vehicle queue. So the system constantly compares the two lanes. The lane with the shortest distance reading, so meaning it has the most cars, it automatically grants it a green light. So here you can see green light. Similarly, you need to change the distance of this also. The yellow transition. So whenever the system detects that the priority needs to shift, it outputs a brief yellow light on both sides. So here you can see now both sides showing yellow lights. So this acting as a safety buffer before changing the flow. The green light stays active as long as the specific lane remains more crowded than the other. So you will see the output lock onto the busy lane until the sensor detects that the cars have moved away. You keep on changing the distance, then observe the light changing. If lane A has cars backed up 10 meters and lane B is empty, the system will output green for lane A and red for lane B. Here ulta you are seeing, right? Just keep on changing the distance. The moment lane A clears and the sensor sees the road is empty again, the system will switch the output to favor lane B or return to an idle state. So that's all about the traffic density control system. For more projects, please watch the upcoming videos. Thank you all.